when we graph in intercept form, we're looking for our x-intercepts, and then we kind of deal with the rest of the graph from there. So I'm going to treat this as if this says x minus 3 times x plus 1 equals 0 instead of y to find my zeros or my x-intercept. So I'm going to say x minus 3 equals 0 or x plus 1 equals 0. And I'll add 3 over here, add 3. That'll be x equals 3. Subtract 1 and subtract 1. That would be x equals negative 1. So those are my two x-intercepts. Those are my zeros, really. So x equals 3 would be over here, and then x equals negative 1 would be right there. And my x-intercepts would be, I wish my pen would work a little better, negative 1, 0, and 3, 0. And I know that my axis of symmetry is going to be halfway in between those 2 points, and that's where I'm going to find my vertex. So if I really just count something this close, I have 1, 2, 3, 4, 5 spaces. I'm going to go 1, 1, and then 1 right there. So I know that my axis of symmetry is going to be right in the middle of those two. My axis of symmetry is going to be at x equals 1. So that means that my vertex will have an x value of 1. And in order to find that, I got to plug 1 into this equation right here. So I'm going to use Desmos to plug in all of this stuff. I'm going to say x minus 3, x plus 1. X minus 3, x plus 1. And there's my quadratic. And there's our x-intercepts that we just drew right there. And our axis of symmetry was going through 1 right there. It looks like it's going to be negative 4, but I'm going to create a table, and that's going to kind of help me out right there. I got negative 2, negative 1, 0, 1, 2. I'm going to find 3 and 4. And the reason is because my vertex is right here at 1, negative 4, and that's the bottom of the cup for me. And I know that I'm going to have this mirror thing, this reflection going over this axis of symmetry at x equals 1. So if I were to write x equals 1 right here, I would have a mirror on either side of this, some reflection going on either side. So you can see that right here with negative 3 and negative 3, 0 and 0, and 5 and 5. So I'm going to come back over here and kind of sketch that graph. At 0, it's negative 3. 0, it's negative 3. And then at negative 1, it's 0. Negative 1 at 0, we already had that. And then negative 2 and 5 is right here. And I think that my vertex was at 1, negative 4. So that goes right there. So then I have this mirror thing going on over the axis of symmetry. So my quadratic should look something. Hopefully yours is a little bit smoother than that. But it should look something like that. My y-intercept is where x equals 0, where it crosses the y-axis. That would be at 0, negative 3. Let's look at another one. I've got x minus 7 times x minus 1. I'm going to say x minus 7 equals 0, or x minus 1 equals 0. Add 7 to both sides. That would give me x equals 7. I'm going to add 1 to both sides. That would give me x equals 1. And those are going to be my zeros. That's where it's going to cross the x-axis at. So my x-intercepts would be at 1, 0, and 7, 0. My axis of symmetry is going to go right down the middle of that, so it looks like it's going to be at 4 right there. So x equals 4 is my axis of symmetry, which means that my vertex can be found on there at 4 something. I'm going to go over to Desmos. x minus 7, and x minus 1. And we can see that 4 would cut it in half right there. And I have my table already over here. Let's add a couple over here. And you can see that at 4, we start this mirror thing going over here with, 4, -9 looks like it's my vertex, and then -8 would be the next one, then -5. So I've got 4, -9. 4, -9 is right there. And then I think from our table it said -8 was for 3. I think it said -5 was next. And we've got this reflection going on across this axis of symmetry. And then hopefully your graph will look more like a U-shaped graph than mine. Mine is pitiful. The last question that's asked of us is the y-intercept. So where does x equal 0? I could come over here and see where x equals 0. That looks like it is going to be at 7 on this graph right here. 7. So if I were a better artist, it would have gone through 7 right there. Y-intercept is 0, 7. Find one that's got a negative on it right here. So I've got a negative out front. That's not going to change anything as far as the way I'm going to go about solving it, but it is going to change the way that it looks. The negative out front is going to flip my graph over. So instead of having like a bottom of the cup style, I'm going to have a top of the mountain. So I'll have x plus 3 equals 0 or x plus 1 equals 0. I'll subtract the 3, and that'll give me x equals -3. I'll subtract 1, and that'll give me x equals -1. So those are my zeros. That helps me find my x-intercepts at -3 and -1. I know that my axis of symmetry will be right halfway in between there. So it looks like it's going to be at -2 right there. Cutting the graph in half, that would be at x equals -2. That tells me that my vertex will have an x value of -2. And I can punch that into Desmos. And it sure does have a axis of symmetry at -2. There's an x-intercept. There's another x-intercept. There's my y-intercept right there. And I could look over here at the table to help me find all of that stuff as well. Vertex is going to be at -2, 1. X-intercepts we already said were at -3, 0 and -1, 0. And my y-intercept, let's draw our vertex down here. -2, 1 right there. Y-intercept is going to be -3, -3 right there. And then I think -8 was my next number. We have this reflection, this axis of symmetry. So where it's -3 right there, it's going to go 1, 2, 1, 2 right here. And then 1, 2, 3, 1, 2, 3 right here. And hopefully you can draw a better parabola than I can. Y-intercept is 0, -3.